Now we're with the electronic design team and my colleague Carl. Hi.
Hi.
So tell me, Carl, what do you guys do? What is electronic design?
We are the team that take care of the core electronics. That would be the processors, memories, power management and more. We handle all the schematics and the layout, and we do all the components for that, all the CAD tool components needed.
Cool. So what CAD programs do you guys use?
We use tools from many different vendors, so we are experienced with Siemens, Cadence, Altium and more. And we can basically cater to any needs from different projects and customers. We also have a very experienced battery design team.
Okay.
I have an example here of a battery we have designed. It's made for explosive environments.
Really? Wow.
Goes into a device with 14-layer PCB and over 2,500 components that handle this explosive environment and all the safety that goes along with it.
That sounds like a very, very complicated design. How do you make sure something like that is safe?
For the battery specifically, we have a triplicated safety circuit inside.
Okay.
And the complete thing is potted inside as well.
Wow. So, Carl, tell me, I understand that high-speed digital interfaces is a large focus of what you guys work with. Can you tell me more about that?
Yes, high-speed interfaces is one of our main areas of expertise.
Okay.
So if we look to a camera, for instance, our camera engineers, they are experts in the sensor. But the ED team, the electronics design team, we are responsible for getting the data across to the processor. And for that, you need a high-speed link.
So how fast is high speed? How fast are these interfaces?
Well, we are able to measure up to 25 gigahertz.
Okay.
But typically you need a lower bandwidth to be able to measure that. So we have good margin in our instruments. We can also simulate. So in the simulations, we can look at the impedances and signal waveforms to ensure that we have good quality before we build.
Is that how you ensure, because if you have a design ready, is that how you verify that it's actually correct?
That is right. We both measure and simulate. So we produce small volumes first, but before that, we have even simulated the main interfaces of the board, power integrity, signal integrity, to ensure that we have good quality even in the first boards. And then we measure and follow up and see that simulations are accurate.
So I assume that you guys collaborate a lot with the other teams in the building.
That is correct. We collaborate with all the different teams.
Okay.
So we had this case in one of our projects where the RF engineers, they figured out that they had RF energy going into a power plane in the stack up. We took in the board in the simulation tool, and we were able to see that if we changed the grounding from 3 points to 8 points around a certain via, we could fix the problem.
So, Carl, tell me, what are some of the real-life benefits for your clients with this kind of work?
By using advanced measurements and simulations, we are able to find the design flaws early on and fix them, so we can save costs and time to market.
That's really important. You gain trust in the design and you speed up time to market.
Exactly.
This has been a super fascinating look into the Electronic Design Lab. Thank you so much.
Thank you.
As always, reach out. We can book a lab tour for you and your company. You can come and meet me and Carl in real life. And don't forget, like, subscribe and comment on this video. I'm John. This is Sigma Connectivity.